Autonomic nervous system and revolution in understanding. That is how I called my video. Shall we start? So what I offer is to join the recent revolution in understanding mental health illnesses. Who can benefit from watching this video? So if you suffer with anxiety, palpitations, insomnia, depression, panic attacks, chronic fatigue syndrome, postural orthostatic tachycardia syndrome, fibromyalgia, and other consequences of autonomic nervous dysfunction are considered mental illnesses. So you can benefit. You have tried many things, including meditation, self-hypnosis, calming music, breathing exercises, CBT, cognitive behavioral therapy, and antidepressants or other pills. Nothing helped, and you have lost the hope to ever get better. So this video is about autonomic nervous system, and I'm going to be using abbreviation ANS, about its structure and about its nerve centers, 90 autonomic ganglia. Plural is ganglia and single is ganglion. This video is about scientists who discovered that ANS adapts our body to life, manages stress and even our mood. And this video about parabiosis, the mechanism of distortion of normal work in ganglia cells. So let me introduce myself. My name is Yelena. I'm a Russian living in London, and I suffered with dysautonomia for many years after falling off the bike. I had panic attacks, palpitations, depression, insomnia, brain fog, muscle spasms, etc. I tried talks with psychologists, was offered by doctors. I tried antidepressants, and I couldn't explain why it didn't work for me. So then unexpectedly I found help in my homeland, Russia. I was treated in Moscow in Alexander Belenko's ANS clinic. There I had 10 sessions of intravenous laser. Alexander Belenko was a Russian neurologist. He performed a revolutionary breakthrough in understanding autonomic nervous system. He uncovered, analyzed and synthesized important discoveries of the scientists, mainly Russians. All scientific references and conclusions you find here in this video is his work. Alexander spent his life researching autonomic nervous system and discovered that ANS as a science was destroyed by Stalin. Alexander's major discovery is a local thermoregulation system. Alexander proved that there is not one, as it is still widely believed, but two thermoregulation systems in our body. First one is general, with the control center in the brain. Second one is a local one, with the control in every autonomic ganglion. Ganglia use their own local axon reflexes to manage heat emission. Alexander's success is based on unprecedented and often forgotten discoveries of the great physiologists like Ivan Pavlov, Nikolai Vedensky, Vladimir Bekhterev, Leon Arbeli, and many others. Alexander, in his clinic, successfully treated more than 3,000 dysautonomia patients. I was one of them. So, let me introduce Kiki. He is a ganglion, a clever little brain of the autonomic nervous system. Obviously, Kiki is a made-up name. I made it up for you to understand it easier. So what Kiki does? He kicks electrons, and together with his brothers, ganglia, manage work of the entire body. That's why I made up this name, Kiki, for you to remember it and understand. Kicks electrons, and also to cure it, you need to kick it. I bet you've never heard of Kiki, but he's the real reason behind some of the brain illnesses considered mental. You wonder why? Because it's a clever little brain. It filters and reduces speed of electrical signals. It generates electrical signals. It manages work of all organs, including brain, and it has a family of 90. Our nervous system is a united mechanism. Being linked up parts, ganglia and the brain depend on each other. And just like a traffic jam on a small railway station disrupts the entire railway, ganglia, if unwell, disrupt the brain function. So let's start from the basics. Around 90 ganglia around the body. They generate, receive, give away and filter electrical commands. Each ganglion has from 800,000 to 1 million nerve cells divided in clusters. Together with their connections and nerve cells in all organs, ganglia form ANS, part of the nervous system. ANS adapts our body to everything, to the weather, walking, digestion, reading, writing, conversing, anything. It maintains body internal temperature, pH balance, balance of different minerals, and lots of other things. As all other parts of nervous system, ANS uses electricity to communicate. It is similar to a busy railway with trains, electrons, having non-stop return journeys. Millions of electrical signals go from the brain to the spinal cord, then through ganglia to all organs, and all the way back to the brain, backwards and forwards, all the time. ANS has 3 identifiable parts. Sympathetic, ganglia reside near the spinal cord. Parasympathetic, ganglia reside close to all organs, and autonomic centers of the brain. ANS also has receptors in all organs. Nerve cells, which send reports and receive commands. ANS doesn't need instructions from the brain and performs its tasks completely independently. It only reports to the brain about the job done. The brain joins the body's control only in case of extremely serious changes or illnesses in the autonomic nervous system. That is why the autonomic nervous system is called autonomic. So how in particular ANS disrupts the brain functions? Imagine how complicated the brain structure is. It has billions of neurons, yet it's only 2 processes that happen in them: excitation and inhibition. A healthy brain has a balance of these 2 processes. Imbalance results in brain neurosis, which in turn affects our mental health. It's hard to believe, but in majority of cases, brain neurosis is the result of the malfunctioning ganglia. So we're going to be talking now about through the brain therapies, and they don't work, unfortunately. Until recent time, doctors prescribed only through the brain therapies to fix mental problems. Well, they still prescribe. These methods are directed to sort out brain neurosis. In the opinion of health advisors, the reason for the neurosis is hidden in the brain. At first glance, widely accepted through the brain recommendations sound helpful. Don't overstress, take antidepressants or calming pills, use CBT and visit psychologists. But with time, After trying one on another, patients realized that these recommendations failed to help. Recent revolution in understanding mental health illnesses is allocating malfunctioning ganglia the main role behind brain neurosis. I'll repeat it, the main role behind the brain neurosis. So through the brain, methods are losing their way to the therapies directly treating ANS. We should all remember that ANS is an independent part of nervous system. It has its own illnesses, thus should be treated independently. So to increase your stress resistance and to tackle the majority of mental health issues, you need to treat ANS directly. So imagine a dry tree. To help dry leaves to get greener and healthier, you need to water roots. The same applies to majority of the brain problems. They have roots in the ANS. To help the brain, you need to fix the roots. Parabiosis. Fixing ANS, and therefore the majority of our mental health problems, is not possible without understanding parabiosis, a major discovery at the turn of 20th century. Parabiosis was invented by Russian physiologist Nikolai Vidensky. He discovered that parabiosis is a coma-like state of nerve cells, the state between life and death. Parabiotic cells don't function, and similar to broken rails disrupting an entire railway, they affect the coordinated work of ANS and the brain. Vidensky discovered that parabiosis is a completely reversible phenomenon, but reversible only after treatment. The main purpose of this treatment is to increase blood flow in the comatose nerve cells. Other than parabiosis, there were many other important ANS discoveries made in Russia. Unfortunately, all of them were forbidden for political reasons by Stalin. Having unlimited power himself, the politician allocated managing power to only one center in the body, which is the brain. In his opinion, autonomic nervous system didn't have the right to send commands. By 1950, Stalin stopped all research related to ANS, completely destroying the science. Since that time, ANS became an invisible part of the nervous system. It was declined its independence and any rights to have its own illnesses. In the absence of science, the field of mental health problems was taken over by psychologists around the world. Despite the physiological laws, they made false statements that the brain is the only reason of all mental problems. Their outdated point of view, sort out the head, the body will follow, is still widespread around the world. Needless to say that convincing the brain to behave doesn't help ganglia to recover. The result is poor. The majority of people with mental health problems don't get cured. And now we're going to be talking about history of ANS research because it's important to understand, and the roots of wrong paths in treating dysautonomia. So how did it happen that in the opinion of health advisors, the management system of our body became invisible and submissive to the brain? A bit of history. Doctors started studying ANS more than 200 years ago. At first, this part of nervous system was called vegetative, translated from Latin as exciting, revitalizing. This name was given to it by French anatomist Xavier Bichat in 1800. Soon, this name changed to autonomic, independent. These two terms characterize the main task of ANS, to provide independently body's life and functions. Next major step in understanding ANS was made at the end of 19th century. Using the nicotine method, Cambridge professor John Langley discovered that ANS is present in the brainstem, spinal cord, chest, and abdomen. Despite the huge breakthrough in understanding structure, Langley mistakenly gave ANS submissive role of wire between the brain and organs. He allocated ANS the task to manage internal organs and vessels, but only with the brain commands. In his view, ANS couldn't have independent illnesses. If ANS has one, it only happens because of problems in the brain. In the 1920s, another researcher, German scientist Dressel, described different disorders and made classification of ANS dysfunction. He decided that the reason behind dysautonomia is neurosis of the autonomic centers of the brain, supporting Langley's view. It's only later that Russian scientists proved by different experiments that autonomic ganglia are independent little brains, that they don't need commands from the brain to function, and that their disorder can cause malfunction of all organs, including the brain, blood vessels, and psyche. If made somewhere else, these revolutionary discoveries would have seen a different fate, spreading scientific word around the world. But they were made in Russia, a country where science was submissive to the state, a country where ANS science was eventually forbidden and unhidden from public eyes for many years. Having no other choice, medical society believed that ganglia are just a wire between brain and organs. Doctors around the world used brain-relaxing therapies. They thought that dysautonomia is caused by brain neurosis, despite the opposing scientific evidence. Having little knowledge or nothing at all, medical society divided into two schools: psychosomatic medicine of psychologists and psychosomatic medicine of physiologists, both using correction of psyche, both failing to cure patients. Fortunately, there were other opinions. Russians made a revolution in ANS research a century ago. So what exactly discovered Russian scientists? Studies of Nikolai Vidensky at the turn of the 20th century showed that each nerve center has its own limit of working capacity, or excitation. If this limit is exceeded, then the nerve center passes into special state, parabiosis. Vidensky didn't study brain or ganglia. For his research, he used a simple apparatus, a muscle and a nerve of a frog. Poor frog. He irrigated a nerve with a special solution so it would acquire characteristics of a nerve center. Vidensky made thousands of experiments. All of them proved the same physiological law. Any nerve center has a limit of stress resistance endurance. If the limit is surpassed, then the nerve center falls in a parabiotic state. This way, Mother Nature prevents nerve cells from death, but as a result, the parabiotic center stops performing its tasks. A few years later, Ivan Pavlov, yeah, remember Pavlov's dogs? He discovered the same mechanism of how the nerve centers work in the thinking part of the brain, the cortex. Pavlov called it safety inhibition. For his research, he was awarded the Nobel Prize in Physiology of Medicine 1904. Although Vidensky and Pavlov used different methods and different parts of nervous system, they researched the same mechanism of excitation and inhibition in the nerve centers. Both of them, despite their differences, concluded the same thing. Experiencing increasing stress, the nerve center goes through 3 stages, from leveling to paradoxical, and then reaching the state when it is fully blocked. Vidensky called it parabiosis, Pavlov protective inhibition. Both scientists researched on how to manage this process. Pavlov used bromine to stop excitation, or caffeine to excite inhibition. In some cases he had results, but his chemical approach did not surpass the time. Vidensky chose a different way. He concentrated on mending the electrical machine of the nervous system and was successful. He knew that parabiosis is an accumulation of electrical charges. They don't move and block the others. The scientist concluded, if shaken up by weak impact, block of electrical charges slowly disappears. Vidensky proved in practice. As parabiosis develops in stages, it disappears in stages, but in the opposite order. As well as discovering parabiosis, a sudden drop of excitation, Vidensky invented perielectroton, characterized on the contrary by high excitability. Frequently, perielectroton focuses near parabiotic cells, but sometimes parabiotic nerve center can influence other centers, creating a remote perielectroton. In 1920, Ivan Pavlov presented Vidensky article about perielectroton in the Bulletin of the Academy of Science of the USSR. In this article, Vidensky gave experimental evidence of perielectroton existence. He pointed out that parabiosis and perielectroton are the universal laws of the nervous system work, and the process happen when the electrical machine of our nervous system fails. Vidensky discovered that the speed of perielectroton is extraordinary. It spreads in the nervous system in almost no time, 2,200 meters per second. Vidensky pupils tried to research perielectroton, but it is still a mystery what energy it is based on. Unfortunately, Vidensky's work, in particular his view on parabiosis as a basis of nervous system work, was difficult to understand. This is one of the reasons why Vidensky's point of view didn't spread around the world. At the beginning of the 20th century, scientists looked at the inhibition as a special form of fatigue of nervous centers. Vidensky considered inhibition as a special, inactive form of excitation. He called it restful. Not only scientists of different schools, but his own colleagues could not understand Vidensky's genius work. Even his best pupil, Alexei Ukhtomsky, took long 10 years to accept Vidensky's point of view. In 1920, Vidensky and Ukhtomsky published their last joint article, Work of the Brain Centers, where Vidensky's discoveries were confirmed on warm-blooded animals. Vidensky's work was only understood by Leon Arbeli, Pavlov's best student. Arbeli researched ANS for more than 30 years. He had an internship in John Langley's laboratory in 1910 and 11. By 1940, he headed wide-scale research in 8 medical institutions in Russia. One of his most important discoveries showed that not only the brain protects itself from death by protective inhibition, but it also has external protection. These protectors are autonomic ganglia in the neck. They provide all the vital functions of the brain. The more intense the brain work, the more intensive the neck autonomic ganglia work. They are its service managers. Headed by Arbeli, experiments on the top neck ganglia showed that these nerve centers directly influence the mental state. When scientists removed the top neck ganglia in experimental dogs, poor dogs, the animals showed a state assessed as depression. The dogs didn't want anything, exhibiting no activities or interest. Moreover, after surgery, the experimental dogs were losing the majority of the skills acquired throughout their lives. These experiments were against Pavlov's view. He believed that if protective inhibition happens in one center of the cerebral cortex and the center ceases to work, then the work of certain internal organs will be disrupted. He believed that the cerebral cortex controls their work and autonomic centers don't participate in this control. However, further studies of Pavlov's other student, Alexei Spiransky, found that the malfunction of the internal organs occurs when a malfunction of any part of the nervous system happens, including ganglia. Spiransky discovered that the entire nervous system works as a single mechanism, a network from the brain to the individual nerves of the arms and legs. A failure in the function of one member of this mechanism violates the whole coordinated work of the entire nervous system. Then problems in the internal organs occur. Spiransky also found that with every disease inside the nervous system, a pathological subsystem, a system inside the system, arises. This persistent subsystem consists of individual links. The link from the autonomic ganglia plays a key role in it. At the same time, another researcher, a student of Nikolai Vidensky, Ilya Arshavsky, discovered that with strong excitement, ganglia fall into a state of parabiosis. He experimentally confirmed Vidensky research. If Vidensky used a muscle and a nerve center of a frog, Ilya Arshavsky confirmed the law of parabiosis development on autonomic nerve centers, ganglia. Alexei Ukhtomsky, another Vidensky student, discovered that parabiotic nerve center starts dominating in the nervous system. It becomes a persistent focus of excitement, which instantly flares up from any stress in the body. Imagine if the neck ganglion is overstressed and weakened, but it needs to provide intense brain work. The harder the brain works, the harder the ganglion works. Ganglia have their performing limit, so their cells fall into protective inhibition, parabiosis. The brain still needs to cope with stress, so what happens? The brain is weakening because the ganglion stopped working. With time, the brain also falls into overexcited protective inhibition, neurosis. The cause of the neurosis is the ganglion, so the ganglion should be treated. Healthy ganglia pass so few nerve impulses into the brain that they cannot cause noticeable excitement in it. There would be no sensations from the internal organs' work. For the first time, the ability of ganglia to filter electrical signals in the nervous system, safeguarding the brain from being overstressed, was described by academician Vladimir Bekhterev in 1903. Brain nerve cells send signals to the spinal cord nerve cells. They in turn transmit signals to the ANS cells. From there, the impulses spread in all directions to all organs. Similarly, signals are constantly being collected back. ANS filter all nerve impulses and strongly weaken them. Not only quantity, but speed of electrical signals is significantly reduced in ganglia. If the speed of spreading signals in the brain is 8 to 10 meters per second, in ganglia it's only 2 to 4 meters per second. If ganglia didn't have filtering ability, then our brain would be a boiling pot. It would be overstressed with anxiety and had a broken mechanism of excitation and inhibition. This is how deep neurosis develops as a consequence of malfunctioning ganglia. So why doctors don't know about ANS? Extensive research of the three scientific schools, Pavlov's, Vidensky's, and Bekterev's, shows that ANS is an independent part of central nervous system. ANS doesn't need commands from the brain and only reports to it about the work all of the organs. That is why ANS should be treated independently. Conclusions like that should have formed the whole ANS science, helping patients to recover. It would only be a question of time for the analytical work to occur, but it didn't happen. The scientific schools worked in their own directions and did not intersect. Then World War II began and there was no time for scientific analysis. Moreover, the research happened in the USSR, the country where one politician could rule out the whole science. In 1950, along with genetics, Stalin declared ANS a pseudoscience. All ANS schools were immediately destroyed. The result was the idealization of the Pavlovian direction. In Pavlov's view, an organ failure could happen only in one case, only if the brain was unwell. ANS and its illnesses were not taken into consideration. If genetics has long since recovered, ANS as a science has not. Medical students and practical doctors know nothing about it. That is why millions of people struggle with dysautonomia, but all they get is unsuccessful through the brain therapies. It is only recently that revolutionary breakthrough in understanding ANS was performed by Russian neurologist Alexander Belenko. He uncovered and analyzed the important discoveries of Russian scientists. As a student, Alexander had an internship with Professor Hudas Gershanovich, called the Patriarch of Soviet Neurology. This unique experience helped Belenko to become a chief neurologist at the Baikal-Amur mainline railway. Having flown thousands of kilometers in an emergency helicopter, he was able to help patients with numerous diseases, from injuries, poisoning, to botulism and meningococcal infection. But most often he saw patients with described as small psychiatry problems, either neurological or mental. These people usually had serious internal organ malfunctions and seizures with high blood pressure and palpitations. These patients are treated as mentally ill with antidepressants, tranquilizers, and even antipsychotics, but they are not cured. Seeing that medication doesn't help patients, Alexander succeeded in finding rare books from different scientific schools. He shoveled a mountain of information, gradually creating his own vision of the ANS problem. The result of his work was unexpected. He single-handedly recovered forbidden ANS science and also pushed it forward. He was the first doctor who applied thermal imaging to identify localization of malfunctioning ganglia. He also discovered the local thermoregulation system. Dr. Belenko proved that there is not one, as it's still widely believed, but two thermoregulation systems in our body. The first one is a general thermoregulation system with a control center in the brain, and the second one is a local thermoregulation system with the control in every autonomic ganglion. Ganglia use their own local axon reflexes to manage heat emission. This name was given to this reflex mechanism by John Langley. So what are the reasons of ANS dysfunction? As we already know, the main reason of ANS dysfunction is parabiosis of nerve cells in autonomic ganglia. Parabiosis was invented by Nikolai Vidensky. Vidensky discovered that parabiosis is an accumulation of electrical charges. They don't move and block the others. The scientist concluded, if shaken out by weak impact, the block of electrical charges slowly disappears. Gangliopathy is another reason of dysautonomia. Specialists from Mayo Clinic in USA, at the same time with Japanese and Russian scientists, discovered that ganglia can be inflamed. The scientists call this illness autoimmune autonomic gangliopathy, AAG abbreviation. It is one of the reasons of dysautonomia. With AAG, immune system shows a specific response, a few types of antibodies in the blood. So what is the right way to treat dysautonomia? So now we're going to be talking about chemical versus electrical machine approach. who we are. We are an electrical machine, human beings. So more than a century ago, Russian scientists discovered that dysfunction of ANS is the result of violation of its electrical machine. We have already been talking about it. Unfortunately, modern scientists study ANS problems the wrong way around, at the secondary level, chemical. This way, they will never be able to answer the question, why do ganglia suddenly get inflamed? And if you have a look at my picture, you will see that antidepressants, they don't regenerate parabiotic nerve cells. They don't mend electrical machine of nervous system. But what they do, they improve chemical laboratory, but they do it temporarily. Since the root of the problem is unclear, then treatment can only reduce the symptoms. As per scientific publication, it is proposed to treat AAG, gangliopathy, with permanent anti-inflammatory hormones. To successfully treat ANS dysfunction, doctors should start treating its electrical machine first. Sadly, they don't know that ganglia can fall into parabiosis, as Professor Nikolai Vidensky discovered. As a result of parabiosis, ganglion can have autoimmune inflammation, which was found by American scientists. Parabiosis prevents ganglia from over-excitation to avoid physical death of its nerve cells. If the excitation over the permissible threshold, it triggers the protective inhibition, parabiosis. Although all nerve cells survive, they are in a comatose state, meaning that the electrical machine of ANS is also broken. The broken electrical machine disrupts the chemical one. Imbalances appear in the production of adrenaline, acetylcholine, serotonin, and other neurotransmitters. Now it becomes clear that it's absolutely pointless to start treatment of ANS on the chemical level. For example, treating chemical imbalance with antidepressants gives only a temporary effect in less than half of patients. Statistics show that after taking antidepressants, only 1/3 of dysautonomia patients get their symptoms temporarily withdrawn. Antidepressants or any other substances working on chemical level reduce the symptoms, but they do not recover mechanism and physiology of ANS. And the question is, how to help people with dysautonomia? It's time to remind us of Nikolai Vidensky conclusions. If shaken up by weak impact, block of electrical charges in parabiotic ganglia slowly disappears. We should also remember Leon Arbeli's doctrine. A small influence on the sympathetic system decreases its initially high tension. So what did the scientists mean by small influence and weak impact? They meant a physiotherapy which improves blood flow in ganglia. Shaken up by this physiotherapy, parabiotic nerve cells in ganglia start slowly regenerating. Blood flow is a key to recovery. Our body doesn't need anything else and uses its own reserves to recover. So, as you can see in my picture, therapies improving blood flow, what do they do? Regeneration of parabiotic nerve cells, means electrical machine, and then improves chemical laboratory. 1, 2, 3. So start from the right one.